4.6 million years ago. Close your eyes and try to imagine Earth at that time. No cities, no humans as we know them, no agriculture, no fire, no tools. Just raw, primal nature in its most unforgetting form. This is the late Miocene epoch, transitioning into the Pliocene. The world is changing. Africa's climate is shifting from dense forests to open savannas. And in this transforming landscape, a drama of survival is unfolding. One that involves some of the most magnificent creatures to ever walk the earth. Today, we think of ivory as a luxury item, a symbol of wealth, or tragically, a reason elephants are hunted to near extinction. But millions of years ago, ivory wasn't a commodity. It was something far more fundamental. It was a weapon, a tool, a key to survival in a world where only the strongest, the smartest, and the most adaptable could endure. This is the story of how ivory evolved, why it became essential, and what it meant for the creatures that carried it, and for those that faced it. To understand ivory's role in survival, we first need to understand the world it emerged in. 4.6 million years ago, Earth looked nothing like it does today. The continents were in different positions. The climate was warmer, though cooling. And Africa, the cradle of so much evolutionary drama, was undergoing a profound transformation. For millions of years, much of Africa had been covered in dense, tropical forests. These forests were home to early proboscideans, the ancestors of modern elephants. These creatures were smaller, more compact, adapted to moving through thick vegetation. They fed on leaves, fruits, soft plants. Life was relatively abundant. But then, climate change began to reshape everything. Not the rapid, human-caused climate change we're experiencing today, but a slow, relentless shift that occurred over hundreds of thousands of years. Global temperatures were dropping, rainfall patterns were changing, and gradually, inexorably, the forests were retreating. In their place came something new: grasslands, vast open savannas dotted with scattered trees. This was a completely different environment, with different rules, different opportunities, and different dangers. For the animals living through this transition, adaptation wasn't optional, it was survival. Those that couldn't adjust died out. Those that could evolved into new forms, new species, equipped for this new world. The proboscideans faced a critical challenge. Their food sources were changing. The soft, leafy vegetation of the forests was being replaced by tougher grasses. And in these open spaces, new predators emerged. Big cats, hyenas, and pack hunters that could spot prey from miles away. This is where our story truly begins. Because in this crucible of environmental pressure, ivory transformed from a simple anatomical feature into something extraordinary. Let's talk about what ivory actually is, because understanding its nature helps us understand its power. Ivory is not bone, though many people assume it is. It's dentine, a dense, bony tissue that forms teeth. In proboscideans, certain teeth evolved into elongated, continuously growing structures we call tusks. The earliest proboscideans had relatively small tusks, or sometimes none at all. But as the environment changed, these tusks began to grow longer, thicker, stronger. Natural selection was at work. Those individuals with better tusks had advantages, and those advantages meant survival, which meant passing on their genes. But why tusks? What made this particular adaptation so successful? First, tusks were weapons. In the dangerous savannas, where predators lurked and competition for resources was fierce, having a built-in defense system was invaluable. A well-placed tusk could gore an attacking predator, fend off a rival, protect offspring. Tusks turned a herbivore into a formidable opponent. Second, tusks were tools. Proboscideans used them to dig for water during droughts, to strip bark from trees, to move obstacles, to access food sources other animals couldn't reach. A creature with tusks could survive conditions that would kill others. Third, tusks were signals. Large, impressive tusks indicated health, strength, genetic fitness. They played a role in mating. Females could choose males with the best tusks, ensuring their offspring inherited strong traits. Males competed, displaying and sometimes fighting with their tusks. But there's another dimension to the story that's often overlooked. Tusks weren't just for the proboscideans themselves. They shaped the entire ecosystem. When an elephant uses its tusks to strip bark from a tree, it's creating habitat for insects. When it digs for water, it's creating water holes that other animals will use. When it pushes over trees, it's opening up the landscape, allowing new growth. Ivory-bearing creatures were ecosystem engineers, and their tusks were the tools that reshaped their world. 4.6 million years ago, Africa's savannas were home to creatures that would seem alien to us today. This was the age of megafauna, massive animals that dominated the landscape. Among the proboscideans of this era were species like Ananchus, Dinotherium, and early members of the elephant lineage. Some had straight tusks, some had curved tusks, some even had downward curving tusks in the lower jaw. Each design served specific purposes, adapted to specific lifestyles. But these giants didn't roam unchallenged. The predators of this era were equally impressive. Saber-toothed cats prowled the grasslands. These weren't the famous Smilodon, that came later, but their equally fearsome predecessors. With elongated canine teeth designed to slice through thick hide and muscle, they could take down prey many times their size. Giant hyenas, much larger than their modern descendants, hunted in packs. They had bone-crushing jaws that could crack open the largest bones to access nutritious marrow. Early big cats, ancestors of lions and leopards, were developing their own hunting strategies: ambush predation, cooperative hunting, stalking through the tall grass. For young proboscideans especially, the world was incredibly dangerous. A calf separated from its mother was easy prey. Even adults, if sick, injured, or isolated, could be vulnerable. This is where ivory became a weapon of survival in the most literal sense. A mother elephant, facing down a predator threatening her calf, had one decisive advantage: her tusks. With a sweep of her head, she could impale a saber-toothed cat. With a charge, she could scatter a pack of hyenas. The ivory wasn't just decoration. It was the difference between life and death. There's evidence from fossil sites showing healed wounds on proboscidean bones, injuries consistent with predator attacks that the animal survived. And there's evidence of predator fossils with injuries consistent with being gored by tusks. This was warfare, pure and simple, and ivory was one of nature's most effective weapons. But the story, it's more complex, because proboscideans didn't just defend against predators, they competed with each other. Male proboscideans, like modern elephants, engaged in fierce battles for mating rights. They would clash, tusks locked, pushing and wrestling, each trying to overpower the other. These battles could last hours. Sometimes they resulted in serious injury or death. Fossil evidence shows broken tusks, fractured skulls, puncture wounds, the scars of the ancient contests. The largest, strongest males with the best tusks won these battles, earned mating privileges, and passed their traits to the next generation. Over millions of years, this sexual selection drove tusks to grow larger, longer, more formidable. But ivory's role in survival went beyond combat. In many ways, its most important function was environmental adaptation. The shift from forest to savanna created new challenges that had nothing to do with predators or rivals. Water became scarcer. Food sources changed. The landscape itself became hostile in new ways. During the dry season, water could become desperately scarce. Rivers dried up. Water holes evaporated. Animals died of thirst. But proboscideans with their tusks had an advantage. They could dig. Using their cusks and trunks together, they excavated deep into dry riverbeds, accessing underground water that other animals couldn't reach. This wasn't easy work. It required strength, technique, and most importantly, the right tools. Tusks were those tools. Archaeological and paleontological evidence shows us that elephants and their ancestors have been digging for water for millions of years. In some places, these excavations became permanent features of the landscape, creating springs that persisted year-round, benefiting the entire ecosystem. Food, too, required ivory. The tough grasses of the savanna were difficult to process. But trees still dotted the landscape, and their bark, roots, and inner wood contained nutrients. Proboscideans used their tusks to strip bark, to dig up roots, to break open seed pods that were too tough for other animals. In times of drought or seasonal scarcity, this ability to access alternative food sources could help you provide the difference between survival and starvation. Creatures without tusks or with inferior tusks simply had fewer options. There's another fascinating aspect: mineral acquisition. All animals need minerals: sodium, calcium, phosphorus, and others, for healthy bones, nervous system function, and general health. In some regions, these minerals were scarce in normal food sources, but certain rocks and soils contained concentrated minerals. Proboscideans would use their tusks to dig into cliff faces, excavating mineral-rich earth and consuming it. This behavior, called geophagy, is still observed in modern elephants. It's a direct line connecting us to behaviors that evolved millions of years ago, when ivory first became a tool for accessing essential resources. Here's where the story becomes even more fascinating. The evolution of ivory didn't happen in isolation. It was part of a massive co-evolutionary dance involving countless species. As proboscideans evolved larger tusks and began reshaping their environment, other species adapted to these changes. Some benefited, some suffered, some evolved entirely new strategies. Birds learned to follow herds of proboscideans, knowing that their digging would expose insects and small animals. Certain plant species evolved tougher bark or chemical defenses against tusk damage. Predators developed new hunting techniques to deal with tusk-wielding prey. This is the nature of evolution. It's not individual species changing in isolation, but entire ecosystems shifting and adapting as a unified, though unconscious, system. The fossil record from this period shows an explosion of diversity. New species appearing, old ones going extinct, ecosystems reorganizing. And at the center of much of this change were the proboscideans, using their ivory to transform the landscape. There's a concept in ecology called a keystone species, a species whose impact on the ecosystem is disproportionately large compared to its abundance. Modern elephants are keystone species, and so were their ancient ancestors. Their ivory-driven behaviors maintained biodiversity, created habitat, dispersed seeds, and structured the entire ecological community. Remove the proboscideans and the ecosystem collapses. This happened in some regions where they went extinct, and we can see the effects in the fossil record. Decreased diversity, habitat change, cascading extinctions. The lesson is profound. Ivory wasn't just a weapon of survival for individual animals. It was a tool that shaped the survival of entire ecosystems. The humble tusk, evolved initially perhaps just for defense or display, became one of the most influential anatomical features in the history of life on Earth. 4.6 million years ago, ivory became a weapon of survival. But as we've seen, it was so much more than that. It was a tool that allowed access to water and food. It was a defense against predators. It was a signal of fitness and strength. It was an ecosystem engineer's primary equipment. It was the result of millions of years of natural selection, environmental pressure, and evolutionary innovation. The proboscideans that possessed the best ivory survived. Those that didn't vanished into extinction. Over time, this selective pressure created the magnificent elephants we know today, creatures carrying within their bodies the legacy of millions of years of adaptation. But this story has a tragic coda. Today, ivory is no longer primarily a weapon of survival. For elephants, it has become a liability. Poaching has devastated elephant populations across Africa and Asia. The very feature that once ensured survival now threatens extinction. In the span of just a few decades, humans have done what millions of years of predators, climate change, and environmental pressure couldn't. We have made ivory a death sentence. This makes understanding the ancient history of ivory all the more important. When we look at a tusk, we shouldn't just see a valuable material. We should see 4.6 million years of evolutionary history. We should see a tool that built ecosystems, a weapon that defended life, an adaptation that speaks to the incredible creativity of evolution. The elephants alive today carry this legacy. They are the living descendants of creatures that survived ice ages, volcanic eruptions, shifting climates, and countless predators, all because of ivory. Perhaps understanding this deep history will help us protect what remains. Perhaps seeing tusks not as commodities, but as evolutionary marvels, as weapons of survival that shape the very world we inhabit, will change how we value the creatures that carry them. 4.6 million years of evolution deserves better than extinction. The ivory that once ensured survival should not become the instrument of destruction.